nMOS fabrication process. nMOS fabrication process is used to design a transistor. So this is the symbol for a transistor. It is having source, gate and drain terminal. Our aim is to design a transistor. The application for the transistor will not change, but here this is only the symbol. Our aim is to design a transistor. So this transistor application, we know that while giving the small signal, it amplifies the given input signal. That is the main application for a transistor. So this is only the symbol. I will explain how to fabricate a transistor. So using nMOS fabrication process. Of course, in this process, it is also acted as an source. It is also acted as it stores the data. That's why it stores the data, the transistor. That's why if you want to design a memory card, so it is an array of transistors. All the transistors, array of transistors is also called as, that is, memory card, or else we can design a RAM also, RAM, ROM, everything. If the number of transistors are more, the size of the memory size is high. If the number of transistors are less, the size of the memory size will be decreased, of course. So these are the applications for the transistor. But how to design, how to fabricate a transistor? This is only the symbol. Basic application, as we know that if you want, while giving a small signal, it amplifies the given input signal. So this is the transistor function. I will explain how they are fabricating a transistor. So initially you can see this silicon substrate is there. In a nature, different materials are available from that. So from the silicon substrate, they will cut the wafer from the silicon substrate. So one material, that is silicon substrate, from that one cut the wafer from the silicon substrate. Our aim is nMOS fabrication process. That is the reason we need to take P substrate. P substrate is having holes material. From the silicon substrate we need to take, that is silicon substrate. It is having holes. In the second step, total surface is covered with that is silicon dioxide layer. It gives the protection. Generally, this silicon dioxide layer is used to give the protection for the surface. As I said, our aim is we need to design a source, gate and drain terminals. So in that process, we need to, total surface is covered with the silicon dioxide layer. That is the second step. It gives the protection for the surface. In the second step, that is also named as oxidation process. I think you have seen in so many chips, and in the top side there is a coating with gold color or something. A required coating is there. Means that color, that coating will gives the protection. Like that, here they will coated with SiO2 layer, silicon dioxide layer, on the P substrate. It gives the protection for the surface. And next step, if any odd surface is there, we need to even that. For that, they will go for, that is photoresist layer. Total surface is deposited with on the P substrate. Total surface is deposited with photoresist layer. After oxidation process, this is the oxidation process, and this is the photoresist layer. With this, our aim is to get the even surface. This is the photoresist layer. Photoresist. So now after this we need to get the hot surface to design source and drain terminal. Here after this what they will do, they will pass the UV light. To get the hot surface they will pass the UV light. Total surface is pass the UV light. So here to get the hot surface they will pass the UV light. So this is the SiO2 layer. Of course this is the photoresist layer. So after this part they will go with UV light, they will pass using mask. So this I am assuming this is the mask. This is the mask. So this mask is stop the UV light where the diffusion is required, because here we need to design source and gate terminal. That is the reason here we are not getting hot surface. No need of hot surface. That is the reason here in this area you will stop the UV light. So here only we are passing UV light to get hot surface. So this is the process. Then in the next case what we need to do, this is the main process to design a transistor. Need to design, this is the P substrate, of course having holes, this is the holes material. And in the next step what you need to do, remove the photoresist layer and deposit the polysilicon material to design a gate terminal. Generally polysilicon material is used for to design a gate terminal. This is the polysilicon material, and this is of course P substrate having holes. At the middle of the substrate we are deposited polysilicon material. This is also acted as an P-type gate. So we are already coated with SiO2 layer and photoresist layer. So this is the SiO2 layer. This is the SiO2 layer. So this is an silicon dioxide layer. Of course it is having holes. P substrate is having holes material. Then in the next step our aim is we need to design source, gate, drain terminal. Gate is designed. So next we need to design source and drain terminal. For that, by heating this material we are diffusing electrons into P substrate. We need to diffuse here. You can see this. We need to diffuse this area. So we need to diffuse this area. So because our aim is to design source and drain terminal. For that already P substrate is there. P substrate means it is having holes. So already gate is, we are already designed gate terminal with polysilicon material. It is acted as a gate terminal. Then here we need to diffuse by heating this material. Students, by heating this material we are diffusing electrons into P substrate to design source and drain. Here I am inserting electrons. Just assume this. These are the electrons. It is N. I am diffusing here by heating this material while fabricating. By heating this material they are diffusing electrons here. So this is named as, that is source. This is the source, and this is the named as, that is drain. So of course already we are coated with SiO2 layer. This is the SiO2 layer. So already it is a holes material. These are the holes. So like this, now we can see this, the three terminals they are fabricated: source, gate, drain terminal. So now it is finally it is acted as, while giving small signal it amplifies the given input signal. That is the main application for the transistor. We know that already. The symbol is only, this is only the symbol, source, gate, drain, source, gate, drain. But this is the fabrication process to design a transistor. By heating at the last step, by heating this material, we are diffused electrons into P substrate. Now we can see this is NPN transistor we are designed. So this, after this, again what they will do in the last step, again this surface, total surface is coated with a silicon dioxide layer. It will gives the protection for the surface, and here you can see this is the SiO2 layer. Again they will coat it with SiO2 layer. After designing of source, gate, drain terminal, again they will coat it with SiO2 layer, and even metal also. That metal is used to give the connections to the other devices. That is also named as metallization process. So like this they are fabricating, students, the transistor. As I said, the main application will not change always. The transistor application, it amplifies the given input signal. In that process it stores the data, of course, and for that we need to take one substrate. Using that substrate, the main step is we are deposited polysilicon material at the middle of the substrate. So that is acted as a p-type gate terminal. And then in the next step, to design source and drain terminal, by heating this material we are diffusing electrons. And then we are design, that is source and drain terminals. Thank you. If you have any doubt and suggestions, tell to me.